Open all plan. I'm interested in what page it was, the one with the cables. It's page 83. Okay, so let's close this. Okay, you should go to the unlocked, yes. The only problem is I forgot the page, it was 90 something. '83, from 83 to 83. Okay. Okay, so we'll draw it first. Yes, we need to draw it. Let's try with polyline. We'll go with straight elements and then we will unite them. So I'll go with this line and now with this line. And in between them, I will use this fillet option. No, yes, you can use spline. Yes, you will use spline, you're right. Well, the approximation is not that good. Okay. Now we'll do an offset to make things easier. Well, half of it. Okay, we'll draw the inner as well. Offset didn't help. It's circular. Or I don't know. Yes, yes, just half of it. No, I wanted to make two straight lines and do chamfer between them, but it's okay like this as well. Yeah, yeah. We'll only need to move it outside and then pick up the symmetry line. We'll take it. Because I want to do a mirror of it and then I'll move it. I'll move it in between them. So I want to add some extra elements, which would be this line. And now we'll convert it to a 3D lines and then 3D surfaces and lastly 3D shape. Okay, and now we'll make it 1 meter thick. Now we'll extrude. Then we'll raise it freely in 3D. this is the element, and now we'll do some cross section for the bridge, maybe just to show you how we would create the cable. So I'm going to do a very simple shape only of the outer element. Okay, and this shape we will copy it.
Cine?
Celălalt, Outline Out. Cristi.
Okay, I just want to no, I'll show you. I want to show you again that function where if we have a constant cross section, we can just place our shape across a line, because extrusion only works perpendicular to the surface, while the other works on any shape. Okay. Actually, here. Okay. I can also change colors just to make it more nice. And we can draw that line. For instance, we can start like this. Okay, maybe make it like this. And then we can use this fillet function to make it more realistic, the turning. Okay, and now if we convert this to a 3D, okay, we'll just have to center it somehow to our deck section, and
Nu știu, că aveam o meditație în care nu mai știu fiecare.
De ce să-ți plan și
Caută, pentru că 3 sau 4 locuri sunt acum.
okay, and the function we're going to use is this polyline swept solid. Select the path. This is the path, and the cross section is this one. And in order to place cables, we would need to position some vertical elements. So we can do a box, for instance, here. I can actually start doing them in plane. Okay, and we'll place it now more precisely. Okay, it's better if you work with orthogonal positions. So I only need this in order to be able to have where to connect the cable. So they should stay on some vertical elements that are normally attached to the deck, and they'll have a certain placing. For instance, let's do another 5 copies in this direction. This will be to position the cables. So the cables will be drawn in 2D. Actually, the cables should be drawn according. But this was just an example because we didn't have that big curve. We have some curve on our bridge, but we didn't have that much curve. I only wanted to show again how we can manage if we know a cross section, especially for steel. So if we have a cross section that is constant, we don't need the bridge modular. We can just draw a path and the cross section. And what I'm doing now is a construction line just to show you how the cables would be modeled. Just a second, they need also to, this should be extended upwards a bit. And the cables can be defined with this function from architecture in the roof. Actually, it's called steel timber element, and we can choose here the cross section for the cable. If we here by default it's a rectangular. If we need a circle, we have to draw a 2D circle or any cross section. But we'll draw now a circle and save it in the library. Let's say 0, 5, 1. And I'll save this to the library. Okay, and now we can, this function can be adapted for any custom cross sections or anything we can draw in 2D, and we save in the catalog can be used as cross section for this architecture function called wood steel element. So this steel element actually lets us choose from the catalog a certain cross section. So from the project we'll choose this circle, and here we can scale it, so it can take any dimension we need, as we can scale it afterwards. So we can draw any circle, and then this is how it will fit the endings. So we'll try something like this, and okay. And here is how it will center, if it's going to center the surfaces, or it will go on one side. Midpoint like this. And then we'll have to somehow connect to this pile. So we either, here for instance, I'll do this, I'll set on one side, on the other side. And I see that this cross section is too big, so I'll change it. It doesn't look like a cable, it looks like a pipe. So I'll make it 0, 0. Okay, we would, if we had some vertical elements or some perpendicular elements to the pile, it would be easier. Otherwise, we'll just have to fit them somehow to connect to a certain distance. So normally we would need some construction lines to know exactly where to connect this cable. So as I did here. So if I want to start with the center, I just say midpoint, and this is where the cable begins. And we'll go somewhere around here. Okay, it's we can import the properties from the previous cable. Okay, so we would need some more precision, as we would need to divide the pile in some distances and create some perpendicular elements. So we just connect the diagonals between those perpendicular elements. Otherwise, we try to approximate the same doing now, but we could also try with using the angles we find in the front view. So if we were like this, so, okay, we aren't even the plane. We can work in any view and try to adapt the situation. Even the ending is not okay, it should be like this rather, and it will adapt. So basically this is how we would fit it. So if it's not drawn precisely from the beginning, we can use modification in any window we need. So I can adjust the positioning of it. Okay, we will need to somehow fit with the original drawing. So the original drawing tried to position these connection points on the deck and also on the pile, and then we just click between the two elements. Otherwise it's hard to draw something, but this is the main idea, how it can be drawn. Okay. I'm glad you're saying this. So okay. Well, we should look on the drawing. Exactly. Yes, that's the main idea. Okay, I'm glad to hear this. Okay, anything else for today? Okay, I'm going to save them. Of course. So I'm going to save the report.